I does not equal lowest position and has been sorted be false. That's what the exclamation point means. It means not has been sorted. So it's not going to ask if the current number of 0 is less than the current number of 3. It's going to say, wait a minute, you've been sorted. I shouldn't check if you're lower than me or not because you're already in the sorted array. It's going to skip it. Which means 3 is going to win. It's going to get to that last 3. And this case will work, but this case won't be true. This 3 is not less than our 3 we're holding on to right now. Yes, question.
Doesn't that mean, since it's a double negative, isn't that true then again? So
which one?
I doesn't equal lowest position and it's true. So it has to sort of true because there's a not before true. There has to sort as well. Right?
So if I type this, that means this case will only happen if this is true. Right? If statements require a Boolean condition, they require a true or false. So since he's storing truths and falses, it's just going to ask if this value is true, run the code. If I put an exclamation point, now it's negative. It says if not, if I'm not true. So if I go back to how I wrote it, if you're not I, right, these are two separate conditions. I could have written these as if statements inside each other if I wanted to. Put this back. Cool. All right. So I is 4 right now. And let's make sure that it's not comparing the lowest number to itself. I can even just take this out. This is not ruining my story code. So if that makes it easier to look at, I'll take it out. It's just saying, when I is 4, when we're counting up, make sure that has been sorted of that position is false. It's not true. It's not true. So it's just one negative. So when it gets here, it's going to say, true is not true. And it's going to get skipped.
Because the I is at the end, it's saying it's skipped? Like,
I here?
yes.
It's saying which has been sorted position. Which position in this array?
All right.
Position 0, 1, 2, 3, 4. When it gets to 4, it's not going to run its code. Does that answer your question?
Sort of. Because you took out the other code that had I.
I'm using I.
That's what I was asking.
The alphabet was just saying, I don't want to waste time comparing the number to itself. Because we have to start with an arbitrary lowest number to do all these comparisons, right? We just happen to choose this first value to be our lowest number until proven otherwise, right? So that part where it says if I doesn't equal lowest position is just saying, don't waste your time comparing yourself to yourself, right? If lowest position is 0, and we're currently checking the guy in position 0, he's already the winner. There's no reason to double check it. So I can take that line out, I can take out this part, and it's not going to break anything. I was just saving the computer a little bit of time. Yes, question.
But can you get it back again?
Sure.
So you say if I is not the lowest position, that makes sense to me, that's fine. But then you say if I is not false, and then what you're in the end saying, so you're trying to find one that's true in this case. So shouldn't the exclamation mark in front of has been sorted be gone in this case?
Can I take that out? That will run when has been sorted is true.
And sorry, what does and mean?
That means I just combined two other statements. I'm pretty sure we went over that last week.
Yeah.
I may have just done it quickly.
Just one
If
line.
this makes anyone feel better, I'll do this. You can also write it this way.
This. Okay.
Nothing will change. It's just checking both if statements. Right? So you just do an if statement inside of an if statement, or you could combine these two statements together. And that's what the double ampersand means. It says that both this side of the ampersand and this side of the ampersand have to be equal to true. They both have to be true. If statements only run when things are set to true. So again, let's take this out just to focus on this statement. If I write it this way, since this is going to be a Boolean value, right, think about it this way. this will always work, right? If it just says if true, it's going to execute. Every time we write an if statement, we're writing something that creates the value true. Okay? Even when you're using less than, that's called a Boolean operator. Because it does a mathematical comparison, but returns a Boolean. It returns either true or false. It is a Boolean operation. Okay? And if I write this, now this will never work. It has to be true. This statement's only run when the value in the parentheses is true. Right? So if I write not true, this will only happen if things are false. And true, well, it's not a variable, so I can't change its value. That will always run. Because not false is true. That's why I have to say not has been sorted. You know what, maybe I should just move it hasn't been sorted and just
It's
push
just
everything.
I'm just maybe thinking
Hasn't
mathematical.
been sorted is just a name. So don't read this like a sentence.
That's not the problem for me. I just think if you say,
I can name it anything.
yeah,
It's not Doodle sort.
it's okay.
Just think about it, it's like times -1. Not will turn truths into falses and falses into truths. Alright, let's move on. So we grabbed him, and he couldn't compare, this 3 could not compare against the 0, because that gets us true in our has been sorted array. So if we get back down to these lines again, this is a sorted J. What does J equal on this path?
What are we up to?
How many times have we run that outer for loop?
4 times.
We've only done the outer for loop, we've run this inner for loop. That ran a bunch of times, but this for loop out here. What number are we on? What did you just say?
1.
We've only run it once, so J is 1 right now. So sorted array, the position in our sorted array of 1 equals our new lowest number. So right here, what's our lowest number?
3.
And that's our position. And then it says has been sorted at what position?
Lowest position.
And what's lowest position?
0.
That's now true. Alright, we're going to go to our third run, where J is now, leaving for that 2. J is now 2. What's the first thing we do, right? Inside of our big for loop, we first do this other for loop that does what?
Grab the starting point.
Just grab the starting point. Needs something to compare on. How does this for loop, what's its purpose? What does it do?
It checks to see that we're not comparing against the same number. Or against itself.
It just checks it has not been sorted, right? It just finds the first number that has yet to be sorted. So it'll run through the array has been sorted. It's going to say, oh, can't use the first one. Oh, but I can use this guy. So it's going to give us a starting lowest position and a starting lowest number. So our starting lowest position is 1. That's the first place where there's a false. And the matching number in the input array is a what?
5.
The 5. This for loop finishes. Then it goes to this for loop. And then this for loop, hopefully we're pretty familiar with it, it's going to start at 0, it's going to count to 5. It's going to ask, have you been sorted? If you haven't been sorted, check to see if you're lower than the current lowest number. When this for loop finishes, when this is all done, what will be our lowest position and lowest number? Lowest position will be? It's going to be 1. Or sorry, it's going to be 5. I forgot there are 2 3s in our list, right? So it's going to ask, have you been sorted? And if you haven't been sorted, are you lower than the current lowest number? First going to go here. It's going to go, well, I can't ask you. You've been sorted. It's going to go here. It goes, I can't ask you. You've been sorted, but you're not lower than me because we're the same number. So it goes 12. Say, you haven't been sorted, but you're not lower than me. You haven't been sorted, but you're not lower than me. You've been sorted, so I'll skip you. You've not been sorted, and you're lower than me, so I have a new lowest number and a new lowest position. Position 5, number 3. Then it's going to finish. It's going to go to sorted array at J. J is 2. So position 0, 1, 2 is our new lowest number, 3. Does this start to make sense?
Absolutely.
The next time, it's going to grab the first false inside of has true. If we're starting lowest position and lowest number when J is 3. Say it again.
1.
And lowest number?
5.
It's the 5 at position 1 again, because that is just the first time we find the false here. Then it's going to compare him to everyone else. Are we going to find anyone lower than the 5 who has a false in our has been sorted?
No.
We're not. So J will go up to 4. It'll store 5 right here. Position 1 it has been sorted. We'll get this true. We only have 2 more numbers to sort. So in J4, what's our new starting position and starting number?
12.
We'll scroll this up to help. What's starting position?
2.
And starting number?
12.
Is it going to, when it finishes this for loop, is it going to find anyone lower that is set to false in this array?
Yes.
So what's our new lowest position?
3.
And new lowest number? Position 4, 0, 1, 2, 3, 4, is a 9. Position 4 and it has been sorted, 0, 1, 2, 3, sorry, 0, 1, 2, 3, 4. Oh, we've already sorted the... Sorry, did I write the right number of numbers? Oh, sorry. We're in position 3, J4. I apologize. I'm being very confusing right now. Let me go back to that. There we go. There's the code. Sorted of J, currently is 4, 9. As in sorted of lowest position. I forgot my own code. Lowest position is 3. 0, 1, 2, 3. There we go.
That could probably be pretty bad when we're building codes later, right? To forget our codes when we want to do maintenance to our codes.
Mm-hmm. That's where writing comments is really important. So J is now 5. The first for loop is going to return what answers to these. I'll give you a hint. There's only one false in this array right now. So position, there's 2, and lowest number. The second for loop is going to say, hey, the only one who hasn't been sorted is at position 2. And he's not lower than you. He's the same number. When this finishes, we'll be back down to here. The sorted array at point J is this new lowest number. And the guy at 2, that's true. Now what's going to happen? When this code finishes, our bracket's over, so you go to the top of the bracket, what's going to happen? J is going to go up from 5 to 6, and is 6 less than our array length? No. So it's going to stop. It's going to say, hey, I've filled out the entire sorted array. I'm done. Let's just display the output. We'll go ahead and run it. We'll use the exact same values we used in our notepad. I said length was 6. I said 0. 3, 5, 12, 9, 0, 3. So it's going to sort that to 0, 3, 3, 5, 9, 12. Hooray! Sorted it! How do we feel about this? Does it make sense?
Yeah, a lot better.
Did you understand the programming code, or was it the logic that kind of got you guys hooked up?
The logic.
All right, so maybe we'll focus more on some of logic today, and not syntax. Maybe I'll try and show you guys some simple puzzles. Stuff that's easier, or maybe a set to see. Right? Because was there anything in this code that someone thought, I didn't know that, or I didn't know how to type that, or that's something I don't know how to use? Right? I think the only thing I threw at you was the break, but you don't even need it. Right? It'll still work. I took out the break, I'm going to run it again, I'm going to compile. 6 items, 3, 5, 12,